I hope you are having a good time at home. Because of this unexpected holiday, the university had to close, and then we had to find contingency in order to cover the lectures. Therefore, I record the lectures that we ought to cover during this week, put it on Canvas, and my recommendation for you would be to watch the video, go through the video, do the examples and do the exercises that I would put on Canvas. If I remember correctly, we have started with logarithmic functions. We importantly discussed the equivalent relation of an exponent and a logarithm. In fact, there are two equivalent equations, but the two of them are looking to the problem from different perspectives. In one, we have the base n exponent, we find the result, and the other way, we have the result and the base, we are looking for the exponent. We have studied some properties of the logarithm. Today, to continue the lecture, first of all, we see a couple of examples where we evaluate a given logarithmic function at given points, and then we try to graph. For example, suppose we have the function y is equal to the log of x in the base of 2. And we have another logarithmic function, y is equal to the log of x in the base of 1/2. So here the base is 2, which is bigger than 1. Here the base is 1/2, which is less than 1. Let's evaluate these two functions at some points equal to 4. If x is 4, how much would be y? You basically substitute x with 4. It's 4 to the base of 2, and you know in order to use those logarithms, we just write 4 as 2 squared. Now this 2 comes in at the front of the logarithm, 2 to the log of 2 in the base of 2, which is 2, because this part is 1. Okay, now we see if x is 4, y is, which is the log of 4 in the base of 2, is 2. Okay. Now, if x is 1, suppose x is 1, then y is equal to the log of 1 in the base of 2, which is, you know, it's 0. When x is 1, 1 in the base of any number is 0. Suppose x is 1/2, then y is equal to the log of 1/2 in the base of 2. Now, in order to use those properties, I write 1/2 as a 2 to the power of -1 in the base of 2, which is -1, times the log of 2 in the base of 2, which is, this is 1, you know already, 1 times -1 is -1. Now, let's evaluate the other function which is in this board and some other numbers. Suppose we start with x equal to 1/2, then y is equal to the log of 1/2 in the base of 1/2. As you see, these two numbers are the same, therefore we can use one of those properties, which says that this expression is equal to 1. One would be if x is equal to 1, then y is equal to the log of 1 in the base of 1/2, which is 0. As we said, 1 in any base, the log of 1 in any base is 0. The next point, let's assume x to be equal to 2. Y is equal to the log of 2 in the base of 1/2. Now here is the point we have to use one more property of the logarithm, and in order to use that, I write this is actually the log of 2. 1/2 is 2 to the power -1. I hope you do not have any problem. Why 1/2 is equal to 2 to the power -1. Now moving this in at the front, it becomes inverse 1 divided by -1 times the logarithm of 2 in the base of 2. Now 1 divided by -1 is -1, here it's 1, the result is -1. Now as you can see, for b, when b is bigger than 1, the function is increasing. Increasing means as you increase x, and we see the values of x increasing, it's 1/2, it becomes 1, it becomes 4. What happens to the values of y? It's minus 1, it becomes 0, it becomes 2. Now you see, as we increase x, y also increases. Therefore, if the base is bigger than 1, the logarithmic function is increasing. What happens here? As we increase x, it's 1/2, it's 1, it's 2. What happens to y? It's 1, it becomes 0, it becomes negative 1. Y is decreasing. Here, as we increase x, y is decreasing. Therefore, when b is less than 1, the function is decreasing. In order to graph a logarithmic function, we consider two steps. First, we specify b and we see if the function is increasing or decreasing. Now you remember, if b is bigger than 1, the function is increasing. If b is less than 1, the function is decreasing. First step. Second step is to give three different values to x. Three different values to x. First value should be less than 1. Another value should be 1. And another value, the third value, should be bigger than 1. Remember, we give three different values to x. 1 less than 1, 1, and 1 bigger than 1. Right? With those three values, we find the values of y. As a result, we have three different points of the graph, and we can sketch the graph using those 3 points. Let's see how it works. Consider the example which I had on the board. And that was y is equal to the log of x in the base of 2. And see how can we actually sketch the graph of this function. Step 1 is to check b. b is equal to 2 bigger than 1. This function is increasing. This logarithmic function is increasing. Step 2 is to give three different values to x and find y. And we start with a value which is less than 1. Let's assume 1/2. If x is 1/2, how much would be y? Let's see. Y is equal to the logarithm of 1/2. Instead of x, we just put 1/2 in the base of 2, which is the logarithm of 1/2 is 2 to the power minus 1 to the base of 2, and this is actually minus 1. Therefore, our first point is x 1/2, y minus 1. Now let's give x two more values. Equal to 1, it's very clear that y is equal to the log of 1 in the base of 2, which is 0. That means if x is 1, y is 0. This is our second point. The third point, which is bigger than 1, is, for example, we assume to be 4. If x is 4, how much is y? Y is equal to the logarithm of 4 in the base of 2, which is the logarithm of 2 to the power 2 in the base of 2. 2 comes at the front. 2 times logarithm of 2 in the base of 2, which is 2. Therefore, we say if x is 4, y is 2. Now, how many points do we have? 3 points of the graph we have. First point is x 1/2, y minus 1. Second point is x1, y0. Third point is x4, y2. Okay, now let's go to the xy coordinates and find the location of these 3 points. Okay. This is our y coordinate. This is our x coordinate. This is the origin. And let's see where are actually these points on xy coordinates. First point, x is 1/2. Let's say assume this is 1. 1/2 is here. Okay. 1/2, y is minus 1. Minus 1 somewhere here. Okay, this is the first point of the graph. The second point of the graph, x1, y0. x1, y0 is here. x1, y0. The third point is x4, y2. I said 2, 3, 4. Y is 2, 1, and 2. So this is actually the graph. Now you see already the shape of the graph. The shape of the graph of a logarithmic function is having a curvature, like the exponential function. Now if you connect the points like this and extend it down here, you get the graph of which function? Y is equal to the logarithm of x in the base of 2. Okay, now let's see an example of a logarithmic function whose base is less than 1. That means, let's see the graph of a logarithmic function which is decreasing. Now this function is increasing. Yeah, you see, as we increase x to the right, y is increasing upwards. This is clearly a increasing function. Now let's see a logarithmic function which is decreasing. Okay, I use y is equal to the log of x in the base of 1 over 3. 1 over 3. Okay, the first step, as you saw in the previous example, is to specify b. b is how much? It's 1 over 3, which is less than 1. That means the function is decreasing. Okay, the second step is to give x 3 different values. And as I told you previously, we give a value which is less than 1, 1, and a value which is bigger than 1. Okay, let's start with a value which is less than 1. I give x 1 over 3 and then try to find y. Y is equal to the log of 1 over 3 by, in the base of 1 over 3. As you see, these two numbers are the same, and using one of the properties of the logarithm, the result is 1. Therefore, if x is 1 over 3, y is 1. Okay. Now let's give x 1. If x is 1, it's very clear that y is equal to the log of 1 in the base of 1, which is, in the base of 1 over 3, which is 0. Now, the second point is 1 and 0. The third point, we give a value which is bigger than 1. Let's choose 3. If x is 3, y is equal to the log of 3 in the base of 1 over 3. Now here, in order to simplify this logarithm, we have to use one of the properties and write the logarithm of 3. 1 over 3 is 3 to the power minus 1. Now we move this at the front and inverse it. 1 to the power 1 divided by minus 1 divided by the logarithm of 3 divided by 3. Well, this is minus 1 and this is 1. Minus 1 times 1 is minus 1. Therefore, the third point is x3, y minus 1. Now, going back to the points, once again, we see that first point is x1 over 3, y1. Second point is x1, y0. The third point is x3, y minus 1. Now, having these 3 points, let's go to the xy coordinate and see where are these points. Okay? The first point is x1 over 3, y1. 1 over 3 is somewhere here. When x is 1 over 3, y is 1, 1 is here. This is the first point of the graph. The second point of the graph is x1, y0. That's exactly this one. The third point of the graph is x3, y minus 1. Okay, it's 1, it's 2, it's 3, x minus 1 is somewhere here. Now you see already the shape of the graph? The shape of the graph is looking something like this. Extended above. Now you see, this is the graph of which function? The function y is equal to the log of x in the base of 1 over 3.